Alright, so the next term that I like to discuss in the measure of central tendency, I think this is what we are doing, central tendency. Guys, my handwriting is not that great, so please pardon me. Right, so then I think we have already covered mean, right? We know what is mean. Uh, let's move on to something called as median. And then we'll look into something called as mode. Okay. Now, median is nothing but the central value of a data set in when the values are arranged in an ascending order. For example, if I just take the same ages of all my students, I think if I just recall, it was like 12, 13, 14, then we have 18, then we have 20, then we have 22, then we have 24, 24, and let's say 25 and 30. If I recall it properly, right? So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me make the number of quantities odd over here for a specific purpose. Now, if I arrange all of them in the ascending order, and fortunately for me, all of them are already in the ascending order, right? So 12, 13, 14, 18, 20, 22, 24, 24, 25, 30, and 32. Correct. Now, median is nothing but the middle term over here. Now, if I just try and reach to the middle term, the first term, the last term, the second term, the second last term, the third term, the third last term, fourth term, fourth last, fifth term, fifth last, and now I'm left with the mid value over here, which is 22. So this is my median. This is my median of the value. Okay. So if I arrange the quantities in a certain order, the mid value comes out to be the median, right? Now, if the number of quantities are odd, this will be easy. For example, median will be nothing but equal to, if I just try and find out that number of quantities over here were 11 and the 1, 2, 3, 4, 5, 6th term came out to be my median. The number of quantities were 11 and the 6th term came out to be median. Can you just make up a formula between 11 and 6? Can I make it something like this, that the median was 11 plus 1 upon 2th term, which in this case is 6th term. Now, the formula for median can also be written like this. It will be n plus 1 by 2th term over here. This is n plus 1 by 2th term. That is, if the number of quantities are odd, let's say 131, then 131 plus 1, 132 divided by 2, 66 term will come out to be my median. But this is the case when number of terms are odd. Number of terms are odd, or n is odd in this case. But if n is even, the median will come out to be nothing but the mean of, or the average of, n by 2th. Well, let's take an example first. No, I'll just do one, just the same thing. I'll not include 32 this time. I'll talk about 12, 13, 14, 18, 20, 22, 24, 24, 25, and 30. Again, the same thing. Last term, first term, second term, second last term, third term, third last term, fourth term, fourth last. The problem is now I'm not left with one mid quantity. I'm left with what? Two mid quantities. The number of quantities are even. So in this case, my median is nothing but the central or mean of these two, which in this case will come out to be equal to 21. So median is nothing but the mean of n by 2th, right? I'll just do it. N by 2th, n plus 1 by 2th term. Fair enough? Right? Take it up. I think it's 10. 10 by 2th, that is the 5th term. Right? Oh, I'm so sorry. I think there's a small change in the formula over here. My bad, my bad. Apologies for that. I'll just correct it. A small correction though. So n by 2th plus 1. This is the term, right? So I think 5th, that is 5th and then 6th term. So it will be n by 2th, which is 5th term in this case, and then the 6th term. So the average of 5th and the 6th term will come out to be my median in this case, because there is no one mid value, that is median. Okay. Now, if I look at it, let's look at mode. What do you mean by mode? So mode is nothing but that quantity or that value which is occurring the most number of times over here. For example, if I take the same data, in this case I've taken almost all the values quite different from each other, but we can see 24 is repeating. Rest of the other values are coming only once. So mode of this data, let's say this is age of all the people learning guitar in a class. So it'll be 24, 24, and I can see that this is my mode. So my mode in this case will come out to be equal to what? 24. Simple as that. Now there might be cases in which more than one mode is there. For example, had it been 20, had it not been 20, had it been 22 and 22, in that case both 22 and 24 would have been coming out to be more than once. I mean, would have been twice, occurring twice in the entire data set, right? In that case, I would say that both 22 and 24 are my mode over here. Such kind of models are called as bimodal model, which is, that is, there are more than, in fact there are exactly two modes. If there are more than two modes, I call it multimodal model. Rest of the cases in which there is only one mode, as it is happening in this case, the example that we have taken, it's called as unimodal model. There is only one mode, two modes, and more than two modes. That's the central tendency. Okay. Now, let me leave you with one question over here. Okay, let me leave you with one question which will help us understand what is the application of central tendency. So, let me give you a very simple example over here. It says that, let's say the average age of a class learning guitar. Again, the same example, okay? Or let's say, I think I've taken this example in one of my classes, in fact, more than one of my classes, that if a company wants to plan a marketing campaign for all its customers, and the company, I'm not sure, I know the name of the company, but I think it's a company which produces Oreo biscuit over here. Okay, Oreo biscuit. So what happens is this particular company says that I want to collect the ages of all the people who bought Oreo from a locality on a single day. So plenty of data points were there, because obviously the age of the people who bought Oreo, I mean, they could not be 5 or 10 people. Obviously, across the location would have been many people. It would be in hundreds. And the information, once I took it, somebody passed on the information that I calculated the average of all the people, and I'll give you average, the normal average age of all the people who bought Oreo was 19. I think I took the same number in the previous class, 19. So 19 is the average age, or let me make it slightly more realistic, 19.1 years, right? Or approximately 19. Now, if average comes out to be 19, or let me, on second thoughts, I like to keep it integer only यार, इसको integer ही रखते हैं हम लोग, right? Apologies for the background. Now, point is, my question is, what can you deduce out of this number 19? So, average age of all the people who are buying Oreo from a certain locality comes out to be 19 years. Can I say all my customer or my customer group is late teenagers? Right? Please don't read it in any other way. I'm saying that the fellows who are right now in their late teenagership, they're about to exit teenagership and about to enter into being a young man or young women. Okay. Point is, 19 years is the average age. Can I say that here my customer is 19 years old? Right? What I did, I jotted down the age of all the people who are buying Oreo in a certain locality. Okay, that's what I did. Now, is that good, or is that can I make this inference that the customers are late teenagers? Because if I make this inference, all my marketing activities, promotional activities will be directed towards it, because I'll be going to colleges, right? I'll be going to colleges. I'll be going to let's say party spots over here, because these guys are definitely in college and can be spotted in party spots. I can go for let's say job fairs over here, because a lot of young fellows would be interested in job fairs. I can probably go for my promotional marketing activities over here in these spots over here, isn't it? If I take this assumption that based on the average age of all the people who are buying Oreo is 19 years. Is this a good move is the question. If it is, then great. But if you think that it's not, if it is not, then you have to tell me, or you have to tell to yourself that why is it not a good move, right? And I'll tell you, if I've already given it a thought, it's not a good move to trust only the average. And I'll let you know why. Because if I go for, let's say, I'll take a sample over here, right? I'll take a sample of, let's say, 17, 17, 18, 18, 19. Then we have got around, let me take around 10 values over here. Or probably I'll go for 22, 24. And let me get the average over here. I'm trying to make up a group which is close to 19 and giving me an average age of 19. So right now 1, 2, 3, 4, 5, 6, 7. 19 times 7 comes out to be equal to 133. Let me see how far am I. 34 plus 36 makes it 70, 89, 109, 111 and 135. 135 आता है भाई, मुझे क्या चाहिए था 133 चाहिए था. तो what I do is I'll make a small adjustment. ये 24 को मैं क्या कर देता हूँ 22 कर देता हूँ. I'll make it 22. Alright. Now I can see that the average of this, which is 17, 17, 18, 18, 19, 22 and 22. By the way, this is a multimodal model because 17 coming twice, 18 coming twice and 22 also coming twice. Anyways, that's not the point. So 40 and 40, 80 and 34 is going to give me 114 plus 19 is going to give me 133 and 133 divided by 7 is going to give me 19 as the average age. So average age of this group is coming out to be 19. And it's fine because most of them are in or around 19. But if I make up another data over here, let me put it up in red. Something like, again, 12, 12, 13, 13, okay, 12, 12, 13, 13, and I think I'll make the adjustment over here to be, I think I've reduced it by 5, 5 and 5, 5, 20, right? So I'll just go for something like 25 and another, let's say 27, and this increased by 6, this increased by 5, 11, and I'll increase this by 9. It'll be 31. Now I'll be surprised to see that average of these 7 quantities will also come out to be 19. Well, I hope so. 24, 26, 50, 75, 102 and 33. Correct. The average age of this group is also coming out to be 19. But these two groups are different. Here I can take the assumption that on an average, my target audience is late teenagers. Here I can take that assumption. But here, taking that assumption would be deadly because in fact, none of them are around 19. All of them are either young kids about to enter into their teenagership or somebody who is more towards, a young people. I mean, the second half of their youth kind of a people over here, right? Stepping into middle aged. So the point is, if I now direct all my promotional activities according to this, I will not find a single relevant customer over there because these customers are not there in colleges. Neither are there, neither this set. No, none of them are in colleges. They probably are not in the job fairs because they are education fairs or they are in some other kind of fairs. Party spots, I might find something over here, but the promotional activities will not be that effective. And that's the point. So, conclusively, I can conclusively say that central tendency is insufficient to completely understand data. Completely understand data. The data. I'll make the statement. I think it's a safe statement to make that central tendency, be it mean, the same applies to median as well, right? So mean, median or mode is insufficient alone to comment upon or to give me a very decent and very good understanding of the data. So what should it be? How should I understand my data more is basically our next topic, which is measure of dispersion. Might I remind you that in this series we are actually looking at the entire descriptive statistics is helping you to understand your data. So one way of understanding the data is calculate the mean, but we just found that it might or might not be sufficient. It cannot guarantee that I can take action based on this number. Simple as that. What else do I need to know about my data is what I'm going to see in the measure of dispersion. Let's see that.